In this video, we're going to be talking about how to write functions in function notation with the actual, not just like in the previous video where it was just f or g with variables and we're actually using parent functions, and we're going to be looking at graphs. So this video should help you with Objective 3. So what I'm going to start with is just taking you back to the previous objective. I don't know why it's freezing on me, but we'll just go with it. And so, okay, so f of x. Anything that we put inside the parentheses is a horizontal transformation, and they're liars. Anything that goes outside, either in front or behind, is a vertical transformation, and they tell the truth. So if you move something up, that's plus. If you stretch, that's times the whole number. If it's a compression, it's a fraction. With vertical. With horizontal, it's if you move right, you actually subtract. Or if you horizontally stretch, that's actually a fraction when you put it in there. So take, for example, a function you should hopefully be very, very familiar with, just plain Jane x squared. And I want to write a function that is a parabola, but I move it, let's say, right 4. And let's call it g of x. Because this is a horizontal transformation, it's going to go in parentheses. And it lies. So I'm not going to write plus 4, but minus 4. That's my transform function. And then let's say I want to do, say, down 2, going from my original function. I don't put that in with the x, I put that outside. So down 2 actually would be minus 2. So x squared minus 2. That would be my new function. Say I want to reflect across the x-axis. Let's call this m of x. If I want to reflect across the x-axis, that means that's a vertical transformation because I go from, say, here to here. That I put out in front like this. Now let's talk about the more complicated horizontal transformations. If I want to do, say, let's go over here. If I want to do a reflection across the y-axis, and let's call this k of x. I need to put that negative inside the parentheses like that because it's a horizontal change. Let's say I want to do a vertical stretch of factor 4. I'm running out of function names to call it, but we'll just keep working on it. Since that's a vertical stretch of factor 4, vertical tells the truth, times 4. I didn't have to put that times dot there, but that's just to show you. Vertical stretch, I'm multiplying x squared, my parent function, by 4. But if I want to do, say, a horizontal stretch of factor 4, it looks different. I need to put that in parentheses because that's a horizontal transformation, and it lies. It's not actually 4 times x squared, it's 1/4. You flip it over. Oops, except I didn't need to put the 2 squareds there. So that's what we would have. So just talking about how do you actually write the function given the different transformations, we have to pay attention to whether it goes inside with the x or in front or behind. In other words, outside the parentheses. If it's a horizontal change, it goes inside and it lies. Vertical change, outside tells the truth. So let's look at an example. Given, we've got x squared, which is our purple graph here, we're supposed to write a definition for g of x, which I'm going to assume is this red one here. Let me move this down. Okay, so what I need to figure out is how has it changed? How has it moved? And if I look at my vertex, looks like I go over right 1, 2, 3. So right 3 and up 1, 2, 3, 4. So when I put, so if x squared, if that's where I start, that's my parent function, if I want to put the transformation of right 3 in there, it would look like this, x minus 3 in parentheses. And then if I wanted to do the up 4 part, I just add plus 4 on the outside. And there's my function. Just like that. Remember, horizontals go inside and they lie. Verticals go outside and they tell the truth. Let's get another example. So here we don't have just a translation, we also have a reflection. So remember, reflections, that's where you've got a negative somewhere. It either is going to be outside, like this, or it's going to be inside. This is if it reflects over the x-axis, where it's out in front. And then this is where if it's over the y-axis, it's inside. Now it looks like it's a flip over the x-axis because I go from opening up to opening down. So that means I'm going to have a negative in front. Then I see how it moved. It moved left 1, 2, 3, 4. And up 1, 2, 3, 4, 5. So to do the left 4, that's actually x plus 4 in parentheses squared. Up 5 plus 5. So that's my red function. The next example is going to be a bit trickier because here I'm going to actually show you what happens to the definition of the function when you're actually writing it when you do a reflection across the y-axis. So just to show you how I get these graphs in this program, x cubed, that's the purple. So you see this blue x, it means that's connected. Like if I were to cross or touch the x, it would go away. If I want to put it back on, I drag this blue box over and put it back. It's pretty cool, huh? Now, what I'm going to show you is what you would expect is the function for the red one is actually not right. So what do we see? We see a reflection across the x-axis, so that means I'm going to have a negative x like that. And then I see a translation of left 1, 2, 3, 4. So if I just had those two pieces separate, so say if I just reflected across the x-axis, I'm sorry, the y-axis, I would have g of negative x. If I just did the translation left 4, it would look like this, x plus 4. But when I combine those two things, I have to be very, very careful with how I do it. How I want to do it is I put the negative, and then I put x plus 4. So I'm actually going to have a double set of parentheses. That might kind of be blowing your mind, but so my answer, since this is x cubed, that's my original function, here, I just need to add the cubed here and my g of x. So it's going to kind of trip you up a little bit because actually in your content assessment, they don't have this double set of parentheses. Double sets of parentheses in math is kind of awkward. So how they would actually write it is like this, negative x minus 4. They would distribute that negative. So let me show you, let me prove to you why. So that right there, that matches what I wrote for g of x here. that matches. Okay, and then you probably, like if you were just looking at this and didn't know you had to be careful, you would probably actually write it like this, negative x plus 4. That's how you would probably want to write it, right? Because you've got the reflection across the y-axis, and a shift left 4 that lies, so plus 4. Makes sense, right? Well, that's what's here. So watch what happens. What I'm going to do, because I can only have 2 graphs on here at a time, I'm going to actually take x cubed off. Or let's try that again. Why aren't you doing this? You know, you love technology, but when it causes problems, it's a bit frustrating. Okay, let's try this again. There we go. Now I'm going to turn this on. Look, it's actually not in the correct spot. So this one, again, it's so weird how this happens, but it does. And again, I could explain how this works with the actual function values, but I just want to show you what you have to do. So what you would expect, again, horizontals lie. They're really, really tricky. So you have to be super, super careful. So what I want you to pull away from this, let me take this back off, or at least try to. Let's do this. And put this back on. What you have to be super careful of is whenever you've got a reflection across the y-axis, you put the negative there, but then put parentheses around whatever. If you've got a horizontal translation, like let's say I went right 3, that's what it would look like. If I went, so I did a reflection across the y-axis and went left 5, it would look like that. So you have to be very careful. I know there's at least one question in the content assessment like that. Okay, I think I got one more example. If the graph to the right is transformed 2 units left and 5 units up, what is the new equation of the function? Notice this function is already transformed. The parent function for this is just a v centered at 0, 0. And the v, remember that parent function looks like this, it's absolute value. So f of x, the black one, the one that's already there, from 0, 0, it's moved right 3 and down 4. So that would be x minus 3 minus 4. That's the black one. That's not my final answer, but that's just the black one. Then it says transform it 2 units left and 5 units up. If I want to go 2 units left, that's actually going to be adding 2. Remember, horizontals lie. And if I go 5 units up, vertical transformations tell the truth. I'm going to add 5. So my new function would be x minus 1, oops, plus 1. That would be my answer. So when you see a question like this, again, you could end up having a question like this on the test, on the content assessment. Write the equation for the function they have on the graph based off of where did it move from the origin. That's where we got this black function. Then take the directions of where they want you to transform it. And remember, when you do horizontals, it's the opposite. So if it's left, it's plus, it's right, minus. And then verticals tell the truth. Add it in the right spots, or in the correct spots, and you've got your final function.